Hello, in this episode I'm going to show you how to create a random pattern surface on a piece of wood MDF or any type of panel that you want using the path workbench and then export the G-code to the CNC. Let's get started. First of all, I've created a board which is parametric in a spreadsheet. If you want to know exactly what I did here, there's an episode about creating a parametric board on my channel. Just go to the FreeCAD parametric playlist and you will find everything. I won't explain it now. I also have created values for tool diameter, tool radius and tool height. I will explain it along the video what I use them for. And then Y offset distance, which is half of the board length. I will also explain you why is this. You can see if I go over the field here in content equal board length divided by 2. Let's get started. This is just a simple board and it has this pocket here. It's a pocket of 0.01 millimeters. I will use it just as a guide for my first slot operation, which I will then modify to give the pattern that I want to obtain. Let's take a look at the sketch. It's half of the tool diameter. It's from one end to the other and it's positioned at half the tool diameter from this edge. The pocket is 0.01 millimeters as I told you, because it has to be just a guide. Let's move to the path workbench and start creating our random pattern, our random texture. First of all, I'm going to select the board and create a new job. Of course, I will click OK, modify these dimensions to be 0. It really doesn't matter because I won't be using these boundaries in this operation. I'm going to the tools. I have a pattern tool bit. I will select it. It is just a simple bowl bit and mill with rounded corners. Let's give it some horizontal and vertical speed and the spindle speed. I will now remove the default tool. I'm going to the output tab also to modify the processor to GRBL, and I close the job. And in this job I will select the face of the pocket and click on the slot button. When clicking apply, you can see I have a straight slot here from one end to the other. I have to extend the path start and the path end. I want it to start earlier and after milling the board, and I want to use this Y offset distance, but I cannot enter a formula here, so I will just click OK to close the slot operation. And after selecting it in the tree, I can scroll down and I have those two values here, extend path end and extend path start. Clicking on them and pressing equal or clicking on this icon here, I can enter an expression and I will reference the spreadsheet first. Dot Y offset distance, it's the name of the variable, the alias of the field where I stored this value. I click OK, you can see the result is 200. Let's make exactly the same thing for the path start. Spreadsheet Y offset distance. And now you can see the slotting operation is half of the board to this direction and half of the board longer to this direction. But to get a pattern, I need this slot operation to have a variable z, or variable height of the cutter head along it. For this I have to make a guide. I will hide the board and I'll go to the part design workbench. I will create a new body. I will call it guide because it's the guide for my first operation to give it a waviness along the z-axis, so I can then use it for the pattern. In this guide I will draw a sketch on the YZ plane. I will start with a rectangle. I will roughly draw it in the fourth quadrant in the positive X and negative Y. I will now delete the top line of the rectangle, and for the bottom line I will give it a length constraint. I will press equal to enter a formula, and the formula is spreadsheet board length plus 2 times the spreadsheet Y offset distance, because I want it to cover the whole slotting operation, which is the length of the board, and in each end it has the Y offset. I will move it below the 0. Actually, I will give these two lines, the ends, I will make them equal. I will press E to make them equal, and selecting this point and the origin, I will press the I button, which is vertical constraint, and I will give it a height of 0. I want it to be level with the origin, and between this point and this point I'm going to press L again to set a length. Press equal to enter the formula, and here I will enter spreadsheet Y offset distance. This will make my sketch farther to the left of the origin, with the offset here would be the board and another offset here, because as you remember we've set this distance, the board length, and twice this offset. Of course I can modify its height, I don't really need this, but I will select this point and the origin, and I will give it a vertical constraint equal to the board thickness. And now the sketch is fully constrained, but if I close the sketch you can see that I'm missing the most important part, the one that is going to be the guide. So let's just go here and I will create a helping line starting from this left edge to the right edge. I will zoom in and make sure it is point on object, and I will select the line and click on this button which toggles construction geometry. It will make it construction geometry. I can use it, I can see it here in blue, but it won't show up in the sketch in the end. And I'm going to set the distance between these 2 points, the origin and this line. I will set a vertical constraint equal to the radius of the tool bit. This way I have a visual guide when I'm going to make a wavy line here to avoid the tool bit entering too much in the material. Now let's create the B-spline. Here is the button. I will start from this point, make sure the point-on-point constraint is active, and just randomly click here. Some pieces shorter, some longer. We can adjust it later anyway. And just go to the right and finish the B-spline in this point. Again, make sure it's point on point, and then right click to end the B-spline. Now I will drag these points which give the curve to make it pretty and nice, but at the same time I'll make sure they don't go beyond this blue line or above the x-axis. Here you can see it slightly goes above the x-axis. Actually I leave it like this so you can see what happens when it goes above that axis. I will drag this bottom too and this one too closer to the blue line so it gives a better effect. And now I can close this sketch. You can see, let's look from the right, it's a simple wavy line part of this sketch, and now I can extrude this sketch. Of course you have to make sure that the line that I used as a visual guide is blue, it's construction geometry, otherwise the pad will fail. So I'll create a pad and I'll make the length by pressing equal to the tool diameter. And now I have the slotting operation, I have the board that I want to cut, and I also have this guide, which as you can see is longer than the board. I made it longer so I can move the path to the left or to the right as we are looking now to give the random pattern, to modify where it cuts at certain heights. But as you can see, the slot operation is still a straight line. What we need to do is select the slot operation, go to the path workbench, go to the path menu, go to path dress up and select Z depth correction. Here I can select a file, probe points file, but I don't have such a thing. I want to use this face as a guide, so I will just click OK, and it didn't do anything for now. And here I have to use a macro that you can find on my Patreon page. You just go there, download it, you don't need to subscribe, you can find it there, click on it and simply download it and use it as you like. I will select first the Z correct dress up, hold the control button and select this top face. The order is pretty important, otherwise it will fail. With these two selected, I will go to macro and select the add surface to Z depth correction macro, then I click execute. It takes a little bit of time, and now you can see that my slot operation follows exactly the wavy face. The Z depth, you can see now that it follows exactly the shape of this face. I will just hide the guide for now, we won't really need it anymore. Let me show you the board, and I want to repeat this operation with parallel lines along the width of this body. So I'll select the Z correct dress up and I will click on the array button. You can see it here, it has 3 lines on top of each other. I will just select it. It doesn't have an interface, it just appears here. I will click on it and all the modifications we have to do are from the data tab. So let's make it a little bigger. First of all, let's make sure it's a linear 1D, one dimension array. It is. We will have to set an offset, and I want the offset to be equal to the tool diameter. So I'll press the button for formula editor and I'll write here spreadsheet tool diameter. I press enter and I will have 20 millimeters distance between each passes. But for now I have 0 copies, and I want this to repeat at this interval, the tool diameter, and repeat for the whole width of the board. So I will edit another expression here. I will write spreadsheet board width, and I will divide it, of course, by the value at the x, which is the tool diameter. This will result in an array, but you can see that it goes one step farther away, because the first operation is the initial one, the z-correct dress up. The array only starts at the second interval, so I will need to subtract 1 from these copies. I will just edit the formula right here, -1 after the division, and now all these lines repeat exactly as they should. If I hide the board, you will see that even though it looks pretty nice, all the lines are exactly in the same place. All the waves are parallel to the bottom of the board. This won't give a random pattern at all. It will just give some nice looking board, but it won't be random. Let's go back to the array, and here I have jitter magnitude on x, y, z, jitter percent, and jitter seed. I want it to vary on the y. That's why I have this value here, y offset distance. That's why I've extended the slot operation, the guides, and everything, extended it with that y offset, because I want these lines to be higher or lower, but always mill the material. I will set the magnitude on the y-axis, again with a formula. I'm doing this because I want to be able to easily modify the pattern, the number of repetitions, the distance between them, the tool bit, the size of the board. I want to easily modify them so I can reuse this file as many times as I want for each type of board. So I will write a magnitude equal to the y offset distance. Press enter twice, and still nothing happens because the jitter percent is at 0. This means 0% of the copies will be modified. I want all of them randomly placed. I will write 100 here. It's 100%, and you can see now this seems closer to what I want to do. If I hide the board, you will see that all this waviness is randomly placed. You can modify the guide. I will show you later how to modify it, because it's a little thing that you need to know after modifying the guide. Now let's get back to the array, and I will make a jitter seed of 50. You can play around with this value and choose a pattern that you think will look good. Now what I want to do is to limit these movements, and I still have one thing to solve. You can see that the CNC will move a lot to the left, a lot to the right, maybe it will reach the end stops. So I have to cut this operation just to the size of the board. But if I go to the array and go to path dress up, and select boundary, you can see that I have an error here. Recompute failed. I will just click cancel because it simply won't result in any path. That is because the array doesn't have a clearance height and a safe height. The dress up, the boundary dress up, needs those values, and if it can't find them, it will throw an error and will stop. Here comes the second macro that I've created. You can also download this one from my Patreon page. It's free, you don't have to subscribe, just go there and download it. You can find the link in the description. I'll just go to the macro, and I have this macro, add safe and clearance to array. I'll click, make sure the array is selected, of course, click on execute, and you can see that I have clearance height and safe height. Just so you know, the array can have one or many operations. The macro will process all of those operations and choose the highest clearance and safe height from all those operations. It's the safest way that I was able to come up with for this macro. Now that the array has a clearance height and a safe height, I will go back to path, make sure the array is selected, of course, path dress up, boundary, and now it will take a long time because it's a pretty complex operation. And you can see that the boundary is now active. It limits the movement. I will just increase the extension on the Z, on the top of the Z, because sometimes if the guide has lines that go above the x-axis, as I've explained when drawing the guide, this 1 millimeters Z value might simply cut those movements. I will give it a 10 millimeters just to be safe. Nothing is cut. I will click OK. It will recompute it again because changing the Z value here needs a recomputation. And now you can see that my operation is limited. Of course, I have a 1mm on these two sides because that's how I left the dress up with a 1mm. It's not a problem, but I can see that I still have the initial Z-correct dress up. The first line, it's still way out of bounds. I will go to it, select it, go to path dress up, boundary, and also modify this Z value to 10 just to make sure it won't cut the top of the operation. Click OK, and now I have all the movements limited to the dimensions of the board. If I hide the board now, you can see here that each line is in a different position. This results in different depth. Just like in a V-curve operation, variable depth will result in variable width of the channel, and when combining all this, it will give a very nice pattern. I can use it for doors, for drawer fronts, a lot of things where I want something very interesting, something very unique, and let's face it, pretty easy to make. I'll just save the file, and I have to show you the little things that you need to do when changing values here. If I change the board width, let's say we have a 390mm board width, it takes some time to recompute, but everything works okay. It finished recomputing. Let's also show the board. You can see I can use any type of board, any dimension of board. All the lines are randomly placed. I can also change the tool diameter, the tool radius, the tool height, the board thickness. There are two variables that when changed will require some additional steps. It's the board length and the Y offset distance. Why is that? Let me just show the guide again. Whenever I change the board length or the Y offset, this shape will be modified, but the Z-correct dress up, which already has this surface taken from this guide, it's not a clone, it's just a copy, so that won't be updated. I will have to re-update the map for the Z-correct dress up each time I modify the guide. Modifying the length of the board or the Y offset will result in a modification of the guide, so I will have to reapply the macro on the Z-correct dress up. Let's just give it a try. First of all, I will modify the board width so it recomputes faster, and let's make it shorter. Let's make it 250mm. It recomputes and you will see an error. You can see that the guide created some pretty weird geometry. I will have to go to the sketch. Since I shortened this rectangle, some of the points are out of it. Now I'll have to move them back again. Also in this end, we'll have to drag this point, this handle to modify the curve. I will just raise it a little bit here and move this a little down, and now it looks pretty similar to what I want. And I will click close. Now it's back again at what it was supposed to be, but if I hide the array, you can see that it doesn't follow exactly the shape, because the map that the Z-correct dress up is working with is the old guide. So I will have to go to the Z-correct dress up, select it, hold the control key down, select the face, and run the macro again, add surface to Z depth correction. Now it should recompute everything. It takes a little time, and now you can see that it took the shape as guide and everything is exactly as I want it to be. So whenever I modify the guide, the shape of the guide, or I modify some of these values, I have to reapply to the Z-correct dress up this shape by running the macro. Other than that, what is important to know is that if I now extend the board length, let's make it 500mm long, press the tab. It's very quick, but it's very quick because it actually cannot do the recomputation, because you can see I have an error here. The Z-correct dress up has an index out of range. If I double click it, you will see why, because it is way shorter than the actual guide that I need. So I'll just click cancel. I will select the Z-correct dress up, select this face again, and run the macro again. As I said, each time the guide is modified, that is modifying the shape or modifying the length, I have to rerun the macro add surface to Z depth correction. And now it will take some time to make the calculations, and it will extend the surface that is a guide for the Z-correct dress up and modify all the project accordingly. I can now hide the guide. And if I show the board again, also show the dress up array, the path boundary of the array, I can now hide the board again just to make sure everything is as it should be. So from now on I can reuse this file, just go to the spreadsheet, modify these dimensions. If I modify the length or the shape of the guide, of course, sometimes I might want to modify the shape of the guide, I will have to reapply this shape as a guide surface to the Z-correct dress up operation. Other than that, everything updates immediately after changing the values. It takes some time, but it does the job, and I can mill any type of board with a very interesting pattern. You can use a lot of different tool types here. I've used a bowl bit. By varying the depth of the cut, it will create a wider or a narrower channel. I can increase the radius, I can modify all these dimensions, I can go to the workshop and find a real bit. For example, I can use a V-bit to create patterns, but this is the part where you have to be creative, you have to test it out and create your own patterns using this file. What you need to remember is, in order to be able to do this, you need the two macros. You can go to my Patreon page. Let me just open it in a new incognito window just to show you that you don't need to subscribe, you don't need to do anything. Just open the page, just scroll down. Of course, if you don't want to skip this part, I will be glad and I will be very thankful, but you can just scroll down here, click on the macro, and it simply downloads it. You have the add safe and clearance height to come array, add faces, guide to z depth correction, and some other macros. For each video where I use macros, I will add them here. And also, after making this video, I will upload this file that you can download, use it with this version of FreeCAD. It's 0.21.2. Use it, modify it as you like it, and you can create wonderful patterns on different type of materials. Thank you for watching and see you next time.